All right, let's go ahead and look at some polyatomic practice where we've got polyatomic ions in our ionic formulas. So the first thing we're going to do is take the chemical name, write the cation, the anion, and turn that into our ionic formula. So calcium carbonate. Okay, well, we know calcium already. That one we're familiar with. Calcium is Ca. It's in group 2A, which means it always has a 2 plus charge. Now, carbonate. We know this is a polyatomic ion because of this 8, okay? So if we're not sure, we can always look at our reference sheet and see. So let's go ahead and look at carbonate, and if I look at my reference sheet, I can find my carbonate ion right here, CO3, 2 minus. Now remember, this is a unit. This sticks together. We cannot break this apart. The whole thing has a 2 minus charge. So when I write the anion, I write CO3 because that entire unit is the anion, and the whole thing has a 2 minus charge. Well, if I crisscross this, I can see that this is a 1-to-1 ratio, and because I'm writing one of each of them, I will not write any parentheses because there's only one carbonate ion. So calcium carbonate, CaCO3, written just like this with no parentheses. There's one calcium ion and one carbonate ion. Okay, the next one, ammonium oxide. Okay, well, oxide is familiar. We already know that one. The ammonium one is new. So ammonium is our one polyatomic cation. So again, if I look at my reference sheet, ammonium is my one polyatomic cation. And remember, we don't write the one, it's just on the sheet to make it really clear what the charge is because it might be kind of hard to see, but it's NH4. So this unit, this entire NH4 ion has a +1 charge. So for my cation, I'm writing NH4 plus, and my anion is oxide. Okay, well, oxide we're already familiar with. Oxide is oxygen. It's in group 6A, so it has a 2 minus charge. Okay, well, when I crisscross these, we need to remember that I need 2 ammonium ions, okay? So I need 2 NH4 pluses for every one O2 minus, okay? When you write this as your actual formula, if you say NH4 2O, this is incorrect because what this is saying is that this has 42 hydrogens, which is not what we need. We need 2 ammoniums. So this is when we use parentheses, is when we're showing that we need more than one of that polyatomic ion. So my ionic formula then is parentheses NH4 parentheses 2O. Okay, for the next one, zinc 2 nitrate. So here we have a transition metal where the 2 is telling us that it's a 2 plus charge, and nitrate, the 8, is telling us that it's a polyatomic ion. So our cation is zinc, Cn, with a 2 plus charge from this 2 Roman numeral. The nitrate, well, I can go ahead and look at my chart and find nitrate. Here it is. Nitrate is NO3 1 minus. So this unit, this entire collection of atoms is forming one ion as an NO3 with a 1 minus charge. Okay, now this one is going to be similar to our ammonium oxide before. On this one, we have a zinc, Zn2 plus, and in order to make this neutral, I would need 2 nitrates. Okay, so 2 plus, a minus, and a minus add up to 0. So when I write this as my formula, if I write it like this is incorrect because this is telling me that I have 32 oxygens, but I don't want 32 oxygens. I want 2 nitrates. So this 2 on the outside is telling me that there are 2 units of this nitrate. So my ionic formula is Zn parentheses NO3 2. Potassium phosphate. Okay, well, potassium we are familiar with. Potassium is K+. It's in group 1A. Phosphate, the 8, is telling me that it's a polyatomic ion. So if I check my reference sheet, phosphate is a PO4 3 minus. So my polyatomic ion is PO4 3 minus. Okay, sorry about that. I had a bit of trouble with the recording. So we left off on PO4 3 minus. So the PO4 3 minus is our phosphate anion. So when I crisscross these two, I need 3 pluses for every one PO4 3 minus. So K3 PO4. Now with this, I don't need parentheses around the PO4 phosphate anion because there's only one of them. So I only need one phosphate for every 3 potassium ions. Okay, next is boron hydroxide. So boron, we already know. Boron is a 3 plus because it's in group 3A. Hydroxide, now the "ide" might confuse us a little bit because we're like, oh, "ide," that's like a monatomic ion. But if we look at the root, we have hydro, so hydrogen, and ox, like oxide, so hydrogen and oxygen. So if I check my reference sheet, I have hydroxide as an OH1 minus. So my anion is OH with a 1 minus charge. Now this is where I see students make the most mistakes, specifically with hydroxide, is we have boron 3 plus and hydroxide minus. When we crisscross these charges, okay, and we drop the plus and minus, we have boron OH3. This is what I see students do the most, and this is incorrect because what this is saying is that there are 3 hydrogens, but what we really need are 3 hydroxides. So this is one place to really make sure you've got those parentheses, to have B parentheses OH parentheses 3, showing that you have 3 of the hydroxide units. Okay, next we're going to do is split them apart. So I have NH43P. So if I said this out loud, it's ammonium phosphide. So the first thing that tells me what I've got are these parentheses. That is your clue. So I'm going to divide this up and split this up after my parentheses because that tells me that I've got a polyatomic ion here. So NH4, because it's what's inside of my parentheses, knowing I can't break that up. And this 3 right here is telling me that I have a coefficient of 3. I have 3 NH4s. Well, if I check my chart to get the charge, I can look and see, well, I know it's written first, so it's my only positive cation polyatomic, and it's a +1. Okay, for my anion, I've got phosphorus, which is the phosphide ion, which is something I'm already familiar with. It's in group 5A, so it has a 3 minus charge. My total number of ions, I count this up the same way I have before. There are 3 ammoniums and 1 phosphide, so 3 plus 1 is 4. Okay, next one, COSO4. So the place I'm going to split this up is after the metal. So CO is cobalt. So I'm going to break this up after the metal, which tells me that everything after it is a polyatomic ion. So CO is my cation and SO4 is my anion. Okay, now there's only one of them, one of each of them, because there's no parentheses around the SO4, so there's only one. And there's only one cobalt because there's no subscript. Now, we do not pull this 4 out. That 4 is attached to the oxygen. It is a unit, okay? Now, the problem is cobalt is a transition metal, so I need to figure out what the charge of this cobalt is going to be, and I'm going to do that using my sulfate. So SO4 is sulfate. So if I look on my chart and I find sulfate, SO4 is sulfate's SO4 2 minus. So I know that my charge of my sulfate is 2 minus. Okay, well, since I only have one sulfate, because there's no parentheses telling me there's more than one, like there was in this first example, my total negative charge is 2 negative, which means my total positive charge is 2 positive, because you have to have a net neutral compound. And since cobalt, there's only one of them, the cobalt must be a 2 plus. So this is cobalt 2 sulfate. My total number of ions is there's 1 cobalt and 1 sulfate for a total of 2. Remember, this is a unit, okay? We cannot break it up, and it's counted as 1. So let's look at the next example. Li3PO4, so lithium phosphate. So again, I'm going to break this up right after this metal because I know that everything after it is going to be my polyatomic ion. So Li is my cation. There are 3 of them. Okay, so I write my coefficient 3 coming from the subscript. Now, we already know the charge of lithium is a +1 because it's in group 1A. So that is a standard monatomic main group element ion. The PO4 is our anion. And again, we do not pull the 4 out because it's part of the unit. The only way we would have a coefficient here is if there were parentheses, like in the first example. I check my chart. Phosphate is PO4 3 minus. So my charge on phosphate is 3 negative. And again, you can check to make sure you're doing it right, is if your pluses add up to your minuses to equal 0. Your total number of ions are 3 lithium plus 1 phosphate is a total of 4 ions. Okay, now this next one looks a little weird because we have iron and we have manganese, which are both metals. But the manganese is in parentheses with an oxygen. So this right here must be a polyatomic ion because it's paired with oxygen in parentheses with a cation. So I'm going to break this up right here in between my iron and my manganese and oxygen ion, which is called permanganate. So my cation is Fe, okay, because it's the one before the parentheses. There's only one of them. Now, iron is a transition metal, so we have to figure out its charge. But my anion is whatever is written in these parentheses, MnO4, which is permanganate. Now, this 2 on the outside of the parentheses tells me that there are 2 permanganates, okay? If you're not sure, you can always look at your references to see what this is. So in order to figure this charge out, so I can figure out the charge of the iron, I check my reference page, MnO4 1 minus. This is a -1 charge. So my total negatives then are 2 times 1. So I have -2. I'm out of space, but -2 is my total minuses, which means +2 are my total pluses. Because it has to add up to 0, which means my iron must be a 2 plus because there's only one of them. So this formula right here, if I said it aloud, or the chemical name, would be iron 2 permanganate. Your total number of ions is 1 iron and 2 permanganate units for a total of 3. Remember, we don't break this apart, it stays together. And even though this is a metal, it's paired with oxygen, and it is all stuck together in one unit. My last example, K2CrO4, this is very similar to the one above it, but we don't have parentheses. But we know that potassium is a metal, and it is a common cation. So potassium, K, is a +1 always, and there are 2 of them, which we saw from the subscript. Well, then that means that everything after it must be your anion. And I don't pull this 4 out because there are no parentheses. In the example above, there were parentheses to tell us we had 2 permanganates. Here, there are no parentheses, so there's only 1 chromate. So this is called chromate. And if I check my chart to get the charge, you can also figure it out based on your cation. But if I check my chart, I have chromate as a 2 minus. So I fill that in. My total number of ions are 2 plus 1 is 3. So remember, those parentheses are pretty crucial when we're dealing with polyatomic ions. And mark up your formulas to really figure out what ions you have in there. And if you do have transition metals, then you figure out the charge of those transition metals by figuring out your total anion charge and then working backwards, knowing that all ionic compounds have a net neutral charge of 0.